Beneath the surface of our modern world lies a growing tension, an invisible crisis unfolding beneath cities, factories, and fields. Our civilization, powered by innovation and consumption, runs on a finite supply of minerals and metals. Copper, nickel, platinum, rare earth elements. They are the veins and lifeblood of every device, every network, every circuit we depend upon. But these resources are being depleted. Mines grow deeper, costs rise higher, and geopolitical tensions sharpen as nations compete for control of what remains. Our hunger for technology, for clean energy, electric vehicles, smartphones, satellites, is pushing Earth's reserves to their limits. And so, a question begins to echo among scientists, engineers, visionaries. What if the next great gold rush didn't happen on Earth at all, but in space? Beyond our atmosphere, circling the sun in silent solitude, lies a vast wealth of untouched resources. Asteroids, ancient and abundant, each one a treasure chest adrift in the void. This is the story of how asteroid mining could reshape our future, not just by easing Earth's burden, but by transforming how humanity survives, thrives, and reaches for the stars. From the Industrial Revolution to the digital age, human progress has been built upon extraction. We dig, we refine, we consume, and we rarely look back. But the truth is inescapable. Many of the critical minerals that sustain our modern world are running out. Rare earth elements, essential for batteries, solar panels, and wind turbines, are increasingly difficult and expensive to obtain. The mining process itself often leaves ecological scars, toxic runoff, deforestation, habitat loss, and displacement of communities. Meanwhile, demand continues to soar. A single electric car battery can require over 30 kilograms of metals. A communications satellite, hundreds of kilograms more. Global reserves are being stretched, and some economists warn that within just a few decades, shortages could trigger geopolitical instability, economic shocks, and technological stagnation. And so we find ourselves at a crossroads. Do we continue to dig deeper into Earth's crust, or do we look upward toward the silent, glittering rubble fields of the early solar system? Asteroids are not just space rocks. They are ancient, older than Earth itself. Leftovers from the formation of the solar system, they are pristine time capsules of cosmic history. But more than that, they are potential lifelines. Many asteroids, especially those classified as M-type or metallic, are composed of nickel, iron, cobalt, and precious metals like platinum and rhodium, materials that are increasingly rare on Earth. To put it in perspective, a single small asteroid, just a few hundred meters across, could contain more platinum group metals than have ever been mined in all of human history. Another might contain enough water to support entire colonies on the Moon or Mars, or to produce rocket fuel in orbit, breaking our dependence on Earth's gravity well. Thousands of these objects orbit relatively close to Earth, within reach of future mining missions. What once seemed science fiction is now approaching scientific feasibility. The idea of extracting resources from space isn't new. Science fiction writers imagined it decades ago. But today, the tools to make it real are emerging. Advanced propulsion systems, autonomous robotics, artificial intelligence, in situ resource processing, all are converging to create the possibility of industrial operations in deep space. Private companies and national space agencies alike are investing in this vision. NASA has explored missions to study and eventually interact with near-Earth asteroids. Companies like Planetary Resources and Deep Space Industries, though now absorbed or redirected, helped pioneer early designs for asteroid prospecting craft. Their goal was simple: identify asteroids rich in valuable materials, send robotic missions to survey them, and eventually deploy mining infrastructure, perhaps even small-scale factories capable of extracting and refining material on-site. At first, the products might be returned to Earth, rare metals sold to global markets. But in time, the real value may lie off Earth, supplying raw materials to build space habitats, fuel depots, and infrastructure for missions to Mars and beyond. Yet this vision is not without obstacles. Mining an asteroid is unlike any operation on Earth. Gravity is nearly non-existent. Temperatures swing wildly. Communication delays, radiation exposure, and the vast distances involved make every maneuver risky and slow. Then there's the legal gray zone. Who owns an asteroid? The 1967 Outer Space Treaty, signed by over 100 nations, declares that space belongs to all humankind and forbids any nation from claiming celestial bodies. But more recent legislation, such as the U.S. Commercial Space Launch Competitiveness Act, attempts to give private entities rights to materials they extract. This legal tension remains unresolved. If asteroid mining becomes lucrative, how will conflicts be avoided? Will we repeat the mistakes of Earth, with unregulated rushes, exploitation, and inequality? Or will space offer a chance to write new rules, more just and sustainable? And finally, there's the ethical question. Should we mine space at all? Some argue that asteroids are sacred cosmic relics, worthy of protection. Others counter that if responsible space mining can reduce our environmental impact on Earth, it may be not just permissible, but necessary. If asteroid mining succeeds, it could launch a new era, not just of technology, but of economy and civilization. Imagine a future where materials for spacecraft, satellites, and off-world habitats are no longer launched from Earth at great cost, but constructed using metals mined in orbit. Imagine a network of orbital fuel stations supplied by water-rich asteroids, enabling missions deeper into the solar system, faster and more affordably. In this future, economic growth is no longer constrained by Earth's scarcity. The wealth of the solar system becomes accessible, opening the door to industries we can barely imagine: orbital manufacturing, lunar construction, Martian agriculture. Asteroid mining could become the foundation of a space-based economy, one that extends human reach, mitigates terrestrial limits, and redefines what's possible. What's at stake here is not just metal or money. It is the future of civilization. If done wisely, asteroid mining could help us decouple human progress from environmental destruction. It could slow the stripping of Earth's last reserves, reduce pollution, and relieve pressure on ecosystems already at the breaking point. It could also drive new technologies, global cooperation, and a cultural shift toward long-term thinking, toward stewardship rather than exploitation. But if approached carelessly, without foresight or regulation, it could repeat, or even amplify, the extractive habits that have brought Earth to the edge. The choice is not technological. It is moral. It is about the kind of future we want to build. Above us, in the cold quiet between planets, spin the raw materials of tomorrow. Asteroids, formed before Earth even existed, hold the keys to solving some of our greatest challenges, if we choose to unlock them with wisdom, caution, and vision. The path to the stars will not be paved with science alone. It will be shaped by the values we carry into space, values forged on Earth, tested in orbit, and extended across the void. Asteroid mining is not just a technological frontier. It is a chance to rethink our relationship with nature, with resources, and with each other. Because in every rock that drifts through the solar system, there lies not only the wealth of metals, but the wealth of possibility.